we've got to get through. You've got to go away. You've got to go away. You've got to go away. You've got to go away.
It went away.
Okay. We've got to get through. We're on page 3. Yeah, that next one. Yeah, it's in this clip. We've got to get through page 3, and we've really got to get through page 5. But we're gonna make it a fast one. So page 5 and 6 genuinely, but we're gonna make it fast. Okay, we've got to get to extrapolation, which is page 7. So we've actually kind of hit on this yesterday, and this is where you were saying I was the best because you don't actually have to memorize this formula. If you were looking at your formula packet, that 7-page thing we got at the beginning of the year, if you were looking at it, this formula is listed in the packet. So you always have it. So do you have to memorize it? No. In fact, 99% of the time, we're going to just use our calculator to calculate it. And we're going to see the number R, what it is in our calculator, and just like we were doing yesterday with our range from yesterday, as long as it's above a 0.8, we're going to call it strong. Where's that? 0.8, we're going to call it strong. As long as R is between 0.5 and 0.8, we're going to call it moderate. If it's less than 0.5, we're going to call it weak. So 99% of the time, the calculator is going to handle that for you. You're just going to have to interpret from the calculator. But for that 1% of the time, and so we can have a deeper appreciation of our calculator and its wonders, we are going to calculate by hand, in this problem, the R value. So our notes say that here's the formula for R, which again, you don't have to memorize because it's in your formula sheet. It's, you already know what x minus x bar over s of x is. It reminds me of the z-score, but of course, since there's 2 different variables, we have 2 different terms. And that symbol is just a summation, so we're just going to add them all up. The only part, no, it's all fine. Okay, so our example says, using the data from the previous example regarding, we're still on it, SEC football, calculate the correlation coefficient R between points per game and numbers of wins by hand. Then your teacher will show you how to do this with the calculator. Well, we're actually going to do it backwards because you and I calculated it yesterday with the calculator and we got 0.93. So we're going to see if by hand when we calculate it we still get 0.93. But again, 99% of the time, God bless you calculator for handling everything for us. Okay, so xi minus x bar over sx is going to be whatever they gave you as xi, so 34.8 minus x bar was given is 27.07 over sx, that's going to be 7.16. And when we actually calculate that, so 34.8 minus 27.07 divided by 7.16.
Is X initial?
The initial one given, yes. Yes, yes. It reminds me a lot of a z-score. I got 1.0796. So 1.0796. And then it's going to be really nice if we don't actually write it out each time from here on out. So I know in my calculator I'm going to do 36.8 minus 27.7 over 7.16. 25.7 minus 27.7 divided by 7.16. I'm going to repeat this same process. I'm just going to stop writing down that step. So in my calculator, 36.8 minus 27.07 divided by 7.16, I get 1.3589. 25.7 minus 27.07 divided by 7.16, I get negative 0.1913, which makes sense because 25 is smaller than 27, so it makes sense we got a negative that time. Next value is 25.5, So 25.5 minus 27.07 divided by 7.16. I got negative 0.2193. Next one is 32. So 32 minus 27.07 divided by 7.16. We get 0.6885. And you're like, Miss Compton, this is so tedious and it's taking forever. God bless you, calculator, for normally handling this for me. 15.8 minus 27.07 divided by 7.16. We get negative 1.5740. 35.7 minus 27.07 divided by 7.16, and we get 1.2053. 16.1. My goodness. Minus 27.07 divided by 7.16. We get negative 1.5321. Almost done. Getting closer. 25.3 minus 27.07 divided by 7.16. And we get negative 0.2472. Next one down is 30.1. So 30.1 minus 27.07 divided by 7.16. We get 0.4232. 20.3 minus 27.07. Bless you. Bless you for watching, Sally.
I didn't see.
No, bless you for watching and catching my mistake. No. Divided by. I like that. That's funny. We get negative 0.9455. I forgot to pass out number strips, but fictitiously in my head, Sally just got her table to a 6. Because that was funny. 26.7 minus, what was I doing? 27.07. My gosh, I like you. I'm tired of this. Divided by 7.16. And I get negative 0.15. That's wrong. Negative 0.0517. And you're like, oh my goodness, Miss Compton, we're finally done with that column. Yeah, we're done with the X column. We have to do the Y column now.
And then you multiply them? Is that what's going on?
Yeah. So, my gosh. And we're going to keep going just so we fully appreciate our lives, because our lives are so sweet with the God-given calculator.
Is the video from yesterday the calculator trick?
Yes.
Okay.
Yes. Yes. And there's a cute little handout in AP Stats from yesterday, 919, that you need that would tell you the calculator trick too. Look in the stats bucket, look in 19. There's a handout for you. Yeah.
Oh,
It's a great one. Okay, so now we've got to change things because and this should be easier. So 10 is my yi minus y bar. Well, y bar is 8.08. And s of y is 3.34. So I am happy that I get to type different numbers in the calculator. But you know, on the second line, I'm going to do 11 minus 8.08 divided by 3.34.
Where'd you get 10?
That's what's covered up right here. Isn't that a 10? It's a 12. Bless you. I can't tell. So 12. Yeah, it's yours. It's supposed to be for you. Yes, dear.
I need another Batman logo.
Another Batman logo. Are you with Miss Asbury?
Mm-hmm.
Miss.
I'm going to do this register.
Oh.
Is this just a folder?
Just one?
Yeah.
There you go.
Thank you.
Okay, so. Okay, I'm going to go all the way to the list without you. Okay.
Hit the bottle over here so we can know.
Oh, the clear bottle that's over here? Yeah, I saw it earlier. What about it?
See where it went, so they-
Oh. Okay. Oh. Okay, thank you. I wondered why that was there. I thought I did it earlier. Okay. Okay. True story. So everyone understands where I got the 8.08 and the 3.34 from? And so I've done 12 minus, and on the next one, since it's 11, I'll do 11 minus 8.08 divided by 3.34. 8 minus 8.08. I'm using the Y bar and the SY given.
Yeah, are those always going to be given? Or like, what is that about? Is that just
The fact that they gave it to you for this one. No, you and I both know you might have actually had to add them all up and divide by to get the X bar. As for the SX, probably. Again, in real life, on a free response question, could they expect you to just have this much data on your own and trust you to handle it? No. Because at some point, you and I have made an error. For instance, you know I rounded some of these. Were we even supposed to round? Should I have written them all the way out? Am I going to have a rounding error at the end? So hence, it's too many numbers for you to be calculating by hand. We're doing it now because true statisticians have to. But on the AP Cal test, you're not an AP Cal. At least you're not in the streets today.
But I'm still as a person. Like, it's all my personal. I'm sorry.
Oh, you know, the reflection of me having a scene. I don't know what words I was saying, but yeah, okay. So, yeah. You wouldn't have to actually do it by hand this long because you've been bound to make a mistake by now, as apparently I can type the numbers but can't save the words. 12 minus 8.08 divided by 3.34, I get 1.1737, again, but I'm rounding. So is that bad? I don't know. I mean, like, is it bad overall in life? Probably not. Could it end up affecting us at the end? Possibly slightly. 11 minus 8.08 divided by 3.34. I get 0.8743. 8 minus 8.08 divided by 3.34. I get negative 0.2023. But should I round it to 40 because it was 39? 7 minus 8.08 divided by 3.34.
Wait, what's that number right there?
2240.
Okay.
Oh gosh.
2240. I got 22395, so that's why I said it was 2240.
So why'd you put a 0? Because you just don't need that.
You don't need that, but I've been writing 4 decimals every single time. It looks weird if you don't write it. Then I don't know. In my head. Mackenzie. You said wait. Okay, then I need to do that one again. So 8 minus 8.08 divided by 3.34. Yeah, I still got negative 0.2395.
Yeah, but 122.22.
224.
Oh, it is 0.02.
Yeah, it's 02. I didn't write 22. I wrote 22 instead of 0240. Oh, bless you. It was 02395. So it should be 0240. Can you catch?
I don't know. Okay, thanks.
The answer is yes, you can. That's good. Thank you, Mackenzie. Okay, 7 minus 8.08 divided by 3.34. I got negative 0.3234. And then I got kind of lazy, so I was skipping around a bit. I noticed that 11 happens again later on. I already know the answer for 11 is 0.8743. I see 7 happens later on. We already found the answer for 7. So since 7's repeated, I can still put negative 0.3234. 6 isn't repeated, 5 is, but we haven't done it yet. 2's not, 13's not. Bummer. I was hoping to knock out a ton. 10 minus 8.08 divided by 3.34. I got 0.5749. 10 doesn't happen again. Darn. 5 minus 8.08 divided by 3.34. I got negative 0.9222 because it was 1.5, so I'm going to say that's 9222. So down here where I see 5 happen again, I'm going to put the same number. I only have 3 left. Hot dog. 13 minus 8.08 divided by 3.34. I get 1.4731. 2 minus 8.08 divided by 3.34 divided. Tell me what I did. Negative 1.8204. Did I do something wrong again? Oh, okay. And then last but not least, 6 minus 8.08 divided by 3.34. I get negative 0.6228. So again, this was a royal pain in the tail. We calculated the x minus x bar over s of x. We calculated the y minus y bar over s of y. And now we actually need to put those two things together and multiply. So, and then this is where Miss Compton reaches her limit. But at the same time, we've done it this far. Surely we can finish it, right? If I zoom out super far, can you see, Sally?
Yeah.
Okay. So now for the fun times, we could go back and multiply all the things. Literally multiply them all. So that was 1.0796 times the other, 1.1737. We get 1.2671. When I multiply 1.3589 times 0.8743, I get 1.1881. When I multiply negative 0.1913 times, thankfully they fixed this one for me, negative 0.024, you want to put the extra 0, which Sally is right, is unnecessary, you get positive 0.0046. It was 459, so I'm saying 46. Negative 0.2193 times negative 0.3234, and we get 0.0709. Positive 0.6885 times 0.5749, we get positive 0.3958. Negative 1.574 times negative 0.9222, we get positive 1.4515. Positive 1.2053 times 1.4731, we get 1.7755. Negative 1.5321 times negative 1.8204, we get positive 2.7890. It was 78903. Sally's right. You don't have to write the 0, but I just like to. I just like to. Negative 0.2472 times negative 0.3234. We get positive 0.0799. It's 994, and I'm saying the 4 doesn't round it up, so I'm going to leave it there. 0.4232 times 0.8743. You get positive 0.37, and then there's a bunch. Sally's not going to write those zeros, but I am. Negative 0.9455 times negative 0.9222. You get positive 0.8714, but I'm going to leave it at 19. and then negative 0.0517 times negative 0.6228, you get positive 0.032, and it was 321, but there's a 9 after that, so I'm going to say it's 322. Okay, we did all the things. We did the x column, we did the y column, we did the x times the y column. Sadly enough, we still haven't even calculated r, which is the correlation coefficient. We still have to sum it all up to actually calculate it. Yes, dear?
Is it just coincidence that they all worked out to be positive numbers?
No, and I'm so glad you noticed that. Did anyone else notice that every single time it ended up being a positive number? Isn't that interesting?
That's so interesting.
Isn't that interesting?
Most interesting thing ever.
I think it's super interesting, and in my mind, that shows that there seriously is a strong correlation between the two variables, that when we were negative below our normal expected point scoring, we were also negative in winning. So, you know, like, we expected us to score more points this game. We expected us to get closer to winning that game. In my mind, that's what it says, but I've been wrong before. Okay, now to add up all these things and hopefully not make a typo. So 1.2671 plus 1.1881 plus 0.0046. I'm going to press enter. Plus 0.0709 plus 0.3958 plus 1.4515 plus 1.7755 plus 2.7890 plus 0.0799 plus 0.37 plus 0.8719 plus 0.0322. And we end up getting 10.2965. Again, surely to goodness, somewhere in this I've made a technical typo error, which is why we normally don't get to calculate this by hand, because do we really even trust me? The answer is no. Okay, so the original formula for correlation coefficient was 1 over n minus 1, and then the summation of, and it had the x piece, the xi minus x bar over sx, and it had the y piece. You and I, in the first blue column, did the x's, and the second blue column did the y's, and now you and I summed them up. So we've got all of this, we just haven't done the 1 over n minus 1. So we've got to deal with that and multiply whatever 1 over n minus 1 is times 10.2965. So how many games were we dealing with? Or how many football people or whatever? How many schools were there?
12.
Yeah. There are 12. So n minus 1 would be 12 minus 1. So I need to do 1 over 11 times that bad boy. So in my calculator, I'm just going to do 10.2965. I already have it typed in, so I'm just going to press divided by 11. And I get 0.936.
Where'd you get 12 minus 1?
The number of schools. Because Alabama, Arkansas, if you add up all those people on that list, there are 12 of them.
And the minus 1 comes from where? Just like
The formula says minus 1. You don't want me to go psychoanalytical about why there's minus 1. Okay, so you and I calculated this 10.2965. We said there were 12 schools, so we're going to end up multiplying that 10.2965 times 1 over 11. And lo and behold, we got 0.936045. There's a bunch of things, so I wrote 936 on my paper. Again, you and I did this exact, well, not this exact, we did the easier way yesterday with our calculator. And when we did it, we got R was 0.93 with our calculator. So if I rounded right now, I would probably say 0.94, which seems like even a stronger association than our calculator implied. Did I probably make a typo error? Maybe. Is my calculator rounding differently than me? Maybe. There's lots of little tiny things going on, but regardless, 0.93, 0.94, it's very strongly correlated. Okay, is anyone not truly appreciating the miracle of the calculator? There is a slight, again, 99% chance you don't have to calculate it by hand, and then a slight 1% chance of maybe they want you to do, but not that many things. If they wanted you to do it, maybe like 4 schools, not 12 schools. 12, no, too many things. Because you will make a typo the way I almost made a typo, and you had to save my butt. And then, so all their keys would have to be, if Sally made this typo, is this the answer she got? If Sally made this typo, is this the answer she got? Okay, and now we're going to fly. So, you thought that was slow, and you're so excited to hear, now we're going to fly. So, on the AP test, you'll never be asked to calculate correlation coefficient by hand. It's just to give you an appreciation of the formula. And again, you might be asked not to calculate, but to interpret. You might have to interpret the formula. Okay, as we've been discussing, there's one word I don't want to hear in this chapter, and that word is causation. So, or cause or causation. So, correlation, just because two things are correlated, does not imply there is causation. So, there might be as we discussed, a linear association, a positive association, the stuff we were discussing yesterday with the DOFS acronym. But that does mean we can't assume one variable causes the other. Now, it does seem, with our past example, you would think points does cause a win. And I totally agree with that. But until you and I can statistically back it up, don't do it. Okay, if you change units, your value of R will not change. For instance, if you go from feet to inches, R doesn't change. So never put units with R. Correlation coefficient R is unitless. So never put anything by R besides a number. Okay, correlation can only be calculated if both variables are quantitative. So if you can't draw a scatter plot, you can't fit a line to it, why are you looking at this correlation coefficient? Because the correlation coefficient is telling you how good does this line fit this data. So if you can't fit a line to the data, what the crap are you talking about correlation coefficient for? Okay, correlation does not describe the strength of a curve, rather only a linear relationship. Correlation is strongly affected by a few outlying observations. So if there are outliers, correlation is affected. What was that term we used when something was affected by an outlier? It's even on the screen. If something's affected by an outlier, it's not resistant. So correlation is not resistant. What else wasn't resistant? And are not resistant because they're affected by outliers. Okay, so correlation's great, except if there's an outlier, everything's thrown off. Flip over. I'll say a lot of words about this. I guess I can say it quickly now. You'll hear me now. So if we fit this line to our data, that line's called a regression line. And a regression line, we also can call it line of best fit, least squares regression line. It has lots of different names. So you've got to be used to seeing any of them. I normally say line of best fit because I'm old school and that was algebra ways, so I'm just used to it. Okay, regression is a model for the data. Okay, you're never asked to calculate the equation by hand. But you are given this formula on your formula sheet. Now, you and I both know that kind of looks like y equals mx plus b. They put it in a different order, and they use different variables, but that's what it looks like. So if your calculator calculates stuff for you, b1 is technically what? Is it the slope or the intercept? It's the slope. Whereas b0 is going to be that y-intercept. So what's really annoying, and I know we're going to have to get in the habit of it, in algebra you and I all learned to put slope first and the intercept. In statistics we do it the opposite. In statistics we generally put the slope term second. Are they going to count off because you didn't? Probably not, but you do look kind of goofy. You could calculate the slope with this formula. You could calculate that y-intercept using this formula. In my regular statistics class, we literally had to by hand calculate the slope and the y-intercept using these formulas. But you're not asked to on the AP test. However, they could ask you to solve for an unknown. They might say, yes, dear.
Did you say regular statistics?
Yeah, like in college.
Oh, okay. They're saying there's like a non-AP.
No, like in college. Okay, so, but they could, with this formula, they could say, Alex, we're giving you, we don't know y bar, we're asking you for that. We're going to tell you that the slope is this, and that the intercept is this, and that x bar is this. So you might have to plug in the numbers and solve for y bar. That is possible that you might have to algebraically solve for an unknown. But in that case, they would tell you slope, they would tell you slope, they would tell you the y-intercept, they would tell you x bar, and you would just solve for y bar. And really what they're testing is, does Sally understand that B0 is the y-intercept? Does she understand that B1 is the slope? That's all they would really want to know. That's the only reason why they make you solve. Okay, slope and R always match, which is what Louise was calling stupid yesterday, because, like, how do people not realize that? Positive slope, positive R value. Negative slope, negative R value. In case you need it, underline it. You got that, like, that makes perfect sense, of course, then you're good. In algebra, what is a y-intercept? Statistics, sometimes the y-intercept has a meaning, and sometimes it does not, based on the calculated value of the y-intercept. If you are asked to interpret the meaning of the y-intercept, you would say, so you know, back to statistics is all about the context. So you might want to explain in words what a y-intercept is, relating back to the context, meaning the explanatory variable and the response variable. So you might have to explain the y-intercept, using, in my mind, it's just the context. But they're being very specific. You might have to explain it in reference to the explanatory and the response variable. Okay, you and I have always been calculating slope, and sometimes we forget it has meaning, and you've seen all these different interpretations, especially this last one, dy over dx, or delta y over delta x. You've seen slope like this in calculus, right?
Change the y over change the x.
Change in y over change in x. Rise over run, m. You haven't seen dy over dx? Delta y over delta x? Yes. Don't overthink it. Don't. We could go there, but you don't want me to. Okay, so in stats, slope always has a meaning. God, back to everything needs to reference back to that context. So you need to, if you have a specific slope and it's really large, really small, can you, if the value of the slope is positive, R is positive. If the value of the slope is negative, R is negative. That slope is tied to R, which is tied to the context. Flip. We will come back and work this example tomorrow. I do want to look at one at the bottom, though, just to show you this weirdo table. So what we're praying is that they typed in all the data for you. And like on example 1 on that worksheet I gave you, problem 1 on that worksheet, they've done all the work for you, and you just need to interpret the stuff given. So we get that to R squared. We get that, apparently R squared adjusted. What is S? What is S? And you and I are so used to saying S is standard deviation. But when we're given this, and the next two things are R squared and R squared adjusted, what is S really standing for? Does it say strength? But strength would be relating back to what? The what? What's the thing we just calculated 1,000 times? What's the thing we just calculated by hand? It took us forever. Which is the correlation coefficient. Okay, so if they give you a weirdo table, you still have to be able to read it and interpret it. Yes, and they didn't use R for some reason. That's weird. But they are what they are, and they do what they do. So S is probably for standard deviation. But, oh no, I've said all the words wrong. That's freaking wrong. Ignore all that. S is probably for standard deviation. But you need R. Freak, why did all the words come out all wrong? If they gave you R squared, how would you get R? You take the square root of it. That was so stupid of me. So if they give you R squared is 86.008. Freak. All the words. Math. Yeah, I get to a point where none of the words are coming out right, and I sound stupid, and then I'm just mad. Now I'm just mad. Okay, I'm done saying words because I'm just mad.
That's a good idea.
We are. You could do number 1 on your worksheet to make your life easier. That would make your life easier tomorrow.
Let's come to what if the screen?